and the size of each cell is fixed. The size of each cell is fixed. Okay, size of each cell is fixed. That may be 1 byte, or you can take 2 byte, or the 4 byte. Okay, but in this subject we will consider as the size of the cell is only 1 byte. Okay, but in the real life we are also using the 2 bytes. We are also using the 4 bytes. Okay, we are also using the 2 bytes, and we are also using the 4 bytes. Clear? And we are representing this memory by using m into n bytes. M is the number of cell, and n represents the size of each cell. N represents the size of each cell. So as for example, here if we are going to find the number of cell, then it will start from 0, 1, 2, 3, 4, 5. Means total number of cell equal to 6. And the size of one cell equal to 1 byte. So we will write this is your RAM. RAM equal to 6 into 1 byte. Basically, we will write RAM equal to 6 into 1 byte. What do you mean by 6 into 1 byte? 6 represents the number of cells, and 1 byte basically represents the size of each cell. Same like that, if you are writing 16 into 2 bytes. What do you mean by that? Anyone can tell me what do you mean by that? Anyone?
16 cells with size of 2 bytes.
Each of size 2 bytes.
You can use your chat box. Okay, you can use your chat box. Okay, so the total number of cells equal to 16, and the size of each cell equal to 2 bytes. Okay, as we know, this value we can only write in terms of binary, and this is also called the cell address. Each cell has one unique address. Unique address means it is not like that. If you are giving 0 address to this one, you cannot give the 0 address to this one. Okay, so what we can write, either we can write here the number of cells equal to 5. So we can write the first address is 000, second address is 001, 010, 011, and the 101. Okay, 100. You can also write 1, 2, 3, 4, and 5. Something like that. So what we are writing, first address is your 000, second address is your 001, third address is your 010, fourth address is 010, then 100, then 101. Okay, finally we'll write 101. This is the address of this cell. This is the address of this. Now the question is how to find the size of the address. Size of the address means minimum number of bits required to give the address. Minimum number of bits. What is the minimum number of bits required to give the unique address for all the cells? Okay. So in the previous class we have already discussed, if you are taking n bits, what is the maximum value we can generate? Okay, or what is the maximum value we can generate if we are taking the n bits? What is the maximum value we can generate in decimal? Anyone? What is the maximum value we can generate? 2 to the power n minus 1. What is the total number of value we can generate? What is the total number of value we can generate? Anyone? 2 to the power n. Okay, the total number of value we can generate 2 to the power n. Okay. Now we do that. If we are going to find x number of unique address, we are taking one simple example. If we require the x number of unique address, then can we write the x equal to 2 to the power n? We are taking for n bit, we can generate the x number of unique address. Can we write n equal to log 2 base x? Can we write n equal to log 2 base x? We are taking the log both sides. So we are simply writing the n equal to log 2 base x. Okay. Means if we are going to calculate the number of bits required to generate x number of address, then we can use the formula n equal to log 2 base n. Okay. Number. We are talking about the number. Number means always integer. We cannot take the real number. So as for example, if we are interested to generate 9 number, if you are interested to generate 9 different number or 9 different address, okay, so how to write the formula? If we are going to find the minimum number of bits required to generate 9 different address, can we write n equal to log 2 base 9? Can we write n equal to the minimum number of bits required to generate 9 different address equal to n equal to log 2 base 9? Can we write? Because our main objective is to generate n different type of address, n different type of address. Now we are using the calculator to find the value log 2 base 9. Okay, what is the value? It's coming 3.16. 3.16. Can you tell me what is the minimum number of bits required to generate this 9 address? Can we say 3.16 or can we say 4? Can we say 4 or 3.16? 4. Okay, so we can always write the 4. So if we are going to write, we can write n equal to the final value is upper value of log 2 bits. If we are going to calculate the minimum number of bits required to store or required to generate the x number of unique address, then we always take the floor value, sale value, sale. We always take the sale value or we will always take the upper value. Okay. Now 1:20 is saying like that, can we take the nearest integer? If you are taking the nearest integer, what is the number of unique address you will generate? Anyone? What is the number of unique address you will generate if you are taking the 3? If you are taking 3, what is the number of unique address we generate? Anyone? 8. But our requirement is to generate 9 address. In this case, we cannot use the 3 bits. We can use 4 bits. Okay. To generate the 9 different unique address. How we can generate the 9 different unique address using the 4 bits? Now you can see. 8. Now we are writing. Now you can see these are the 9 unique address. This is the address of first cell, second cell, third cell, fourth cell, fifth cell, sixth cell, seventh cell, eighth cell, and ninth cell. Okay, so we are giving the address like that. The first cell address is 000, second cell address is this one, third cell address is this one, fourth one is this one, fifth one is this one, sixth one is this one, seventh and eighth and ninth. Okay, so these are the address we are generating. Same like that. Now we do that. If you are going to find this is your first RAM, if you are going to purchase one RAM 1024 into 1 byte, can you tell me what is the size of address? What is the size of address? No, address is always unique and it will always in the random, not in the random, in the sequence manner. So that will not take, because we are giving the sequence manner, that will not take. We need only the 9 different address. That's why we are writing this value. We need only the 9 different address. That's why we are writing this value. If you are going to generate 111, that is considered as an invalid address. That is not a valid address. Even if you are writing here 1001, this is invalid address. Your system will not allow to generate these types of address. Okay. I am talking about the sequential manner. We are taking the sequence 0. First one your address 0. Second 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like that. So we are taking in the terms of sequence. Okay. So now here you can see it's in the first RAM or first main memory. We are writing the term called 1024 into 1 byte. Can you tell me what do you mean by this RAM anymore? The number of cell equal to the number of cell 1024, and what is the size of one cell? What is the size of one cell? 1 byte. If we are going to calculate what is the total size of RAM, what is the total size of RAM? What we can say the total size of RAM is 1 kilobyte. 1 kilobyte, or you can also say like that 104 byte. Now the question is, what is the address site? What is the address site, or what is the minimum number of bits required to generate the address for this main memory? Anyone? How to calculate? Again, we have to use the formula log 2 base 1024. Upper value, if you are going to check, it will come 10. So 10 bits is required to generate. Same like that, if you are going for this one 2048. What is the minimum number of bits required? 2048. 11. Okay. 280. If you are writing 280. What is the minimum number of bits required? 280. Anyone? 280. What value it will come? It will come 8 point something. Okay, so basically we will take the upper values. We are taking 9. 15. 15 into 4 bytes. 15. If you are going to generate the 15 different address, what is the size you can take? Okay. If you are going to generate the 11 different address, what is the size we can take? Again, we will take the, okay. And if you are going to generate 915 different address, what is the size we can take? can take. Okay, so if the RAM is given, you can easily calculate the size of the RAM. You can easily calculate the size of the RAM, and you can also calculate what is the address. What is the address? Means the number of bits required to keep the address of this RAM. Number of bits required to keep the address of this RAM. Clear? Okay. Now assume that if you are using one RAM with 2048 into 1 byte. Okay. 2048 into 1 byte. If you are using this types of RAM, okay, 2048 into 1 byte. Can you tell me what is the size of address? Anyone? What is the size of address? Size of address? You have already calculated 11 bits. Okay, 11 bits. So minimum 11 bits is required to generate the different address. Okay. What is the total number of cell? Total number of cell equal to 2048. And what is the size of each cell? Each cell equal to 1 byte. And if you are going to calculate what is the size of whole RAM, the size of whole RAM equal to 2 kilobyte. Okay, fine. Up to here, anyone any doubt? Up to here, anyone any doubt? Simply, we are talking about simple one RAM. If you are taking one simple main memory with size 2048 into 1 byte, then in this case, the size of the address equal to 11 bits, the number of cell equal to 2048, and the size equal to 1 byte, and total size equal to 2 kilobyte. Okay, now you can see. Just wait, just wait. Okay. Now you can see. Now assume that if you are installing one operating system with, because there are two popular 32 bits and second one is your 64 bits. But now assume that you are installing the previous operating system, that is only 8-bit operating system. 8 bits operating system. Okay, we are taking as an example. So if you are installing one operating system in your system, that will generate only 8 bits address. It will generate only 8 bits address. Okay. Now, can you tell me what is the minimum address it will generate? What is the minimum address value? Minimum address value it will generate if you are taking 8 bits. What is the minimum address value it will generate? Anyone? What is the minimum address value it will generate? It will generate 0.00008 times. And if you are going to calculate the decimal value, it will come 0. And what is the maximum address value it will generate? It will generate 255. It will generate 255. 0 to 255. The total number of unique address it will generate 256. The total number of unique address it will generate 256. But the maximum address it will generate 255, and the minimum address it will generate 0. But in your RAM, what is your minimum address? 0. And what is your maximum address? What is your maximum address in the RAM? What is your minimum address? 0. And what is your maximum address? Because we are taking the 11 bits. What is your maximum address? Okay. Just you can see. This is the address generated by. This is the address generated by the system. And this one is the address present in your RAM. Both are totally different. Both are totally different. Okay. Both are totally different. Okay. Here you can see this is an independent RAM. This is your independent RAM. Here you are going to give this 11 bits. And what the system, whatever the operating system you have installed in your system, that will only generate the 8 bits number, 8 bits address. Okay. Now, what is the maximum address present in your RAM? What is the maximum address present in your RAM? Anyone? What is the maximum address? 2047. Okay. Now will tell me here the RAM is only generating the address 0 to 255. Can we say this system is using the memory called 256 to 2047? Can we say the system will use the memory called 256 to 2047? Can we say? Can we say? Because it is not using, always it is generating the address between 0 to 255. But in your actual RAM, you have the capacity to handle up to 11 bits address. But what is the problem when you are installing your operating system? That will only support the 8 bits. That will not supporting the 16 bit. That is not supporting the 32 bit and 64 bit. So if you are installing the lower bits operating system, then in this case you are not effectively utilizing the main memory. You are not effectively utilizing the main memory. The simple concept I have already given one example in the previous class. Now assume that this is your bottom. that will contain 2048 different rooms. Okay, different rooms. If we are talking about the different rooms, that has the 2048 different rooms. Okay, and they are using the binary number to give the room address. Okay, each room has one unique address, and they are using the binary number. Okay, what is the size of this binary number they are using for this hotel? They are using the size of this binary number is 11 bits. Clear? Okay, so they have designed one software where the number of hotel, where the number of rooms equal to 2048, and each room they are giving one address to each room, and they are using the binary number. They are using the binary number. So what is the size of the address? 11 bits. Clear? Up to here, anyone any doubt why we are writing 11 bits? Why we are writing 11 bits? Anyone? Because your whole C concept is based on your memory. The whole C concept is based on your memory. That's why we are asking. So what is the size of address? 11 bits. Okay. 11 bits. Simple concept. Now assume that this is one hotel. Okay. And the total number of room in this hotel is 2048. Okay. The total number of room present in this hotel is 2048. Right? 2048. Okay. If we are going to find what is the minimum number of bits required to generate 2048 address, we can use the formula log 2 base x upper value. Right? Log 2 base x upper value. Okay. Log 2 base x upper value. Okay. Now here you can see. So we are calculating the 11 bits. Okay. Now this hotel A already purchased one software. Okay. Already purchased one software that will generate the room number. That will generate the room number based on the ability of the room. That will generate the room number. Okay. Means this software, basically they are using one software, and this software will generate some room number in a binary form. Okay. So when you are designing this software, what you have done, you are only using the 8 bits to store the hotel address. Okay, you are only using the 8 bits. Okay, when you are designing the software, you are only using the 8 bits to store the hotel address. Okay, so as for example, if you are giving the room B, okay, if you are giving the room number 00002 B, then we are going to store like that. This is a B person, and we are giving this room number. Okay. Now will tell me, if we are using only 8 bits to store the hotel address, what is the maximum value of address you can store? What is the maximum value of address you can store? Because in the software, you are only using 8 bits. Maximum you can store 255. Okay. Now will tell me, if you are using the software, how many rooms you can use, how many rooms you can use, effectively you can use. Anyone? How many rooms effectively you can use? You can only use the 256 rooms. You are not going to use all the room 2048. Why you are not going to use all the room 2048? Because there is something problem in your system, software. Whatever the software you have installed, that is generating only 8 bits number. That is generating only 8 bits number. So in this case, what is the problem arises? You are only using the 256 room. You are not using the rest of the room. You are not using the rest of the room. So next time, what we will do like that, we have to purchase the new software, or we will try to modify the software. And this time we will use the 16 bit to store the address. This time we will use the 16 bits to store the address. 16 bits to store the address. Clear? So if you are going to use the 16 bits to store the address, what is the maximum address you can generate? 2 to the power 16 minus 1. This is the maximum value of address you can generate, and total number of unique address you can generate 2 to the power 16. So in this case, you can easily utilize all the rooms present in your RAM. You can easily utilize all the rooms present in your RAM. Clear? Okay. Now the same like that, I have given one example in the previous class. Okay, if you are using the 32-bit system, okay, 32-bit system. I'm not talking about the RAM. I'm talking about the 32 bits operating system. What do you mean by that? The size of the address, whatever the address generated by the operating system, that size is 32 bits. Okay. If the size is 32 bits, then in this case, can you tell me what is the maximum number of address you can generate? What is the total number of unique address you can generate? 2 to the power 32. 2 to the power 30, what we have considered 2 to the power 30 as a 1 GB. Okay, 1 GB. Okay, so you are generating approximately 4 GB. Okay, 4 GB, or you can say like that, you are generating 2 to the power 30. But whatever the RAM you are using the 16 GB RAM. You are using the 16 GB RAM. If you are using the 16 GB RAM and size of one block is fixed 1 byte, means you are using the 16 GB RAM, is basically you need how much memory? You need 34 bits of memory. Okay, actually you need 34 bits of memory, but in your system you are installing 32 bits, means it will only utilize the 4 GB part of the RAM. It will not utilize the rest 12 GB of your RAM. It will not utilize the rest 12 GB of your RAM. Okay, so that's why nowadays whatever the operating system it is coming, that is coming 64 bits. 64 bits. You can generate 2 to the power 64 different addresses. Okay, you can generate 2 to the power 64 different addresses. Concept is simple. This is your main memory. This is your main memory. Okay, you are installing the main memory. Means main memory, you have one main memory of 16 GB. Okay, size of one block is fixed. What is the size of one block? Size of one block is fixed. What is the size of one block? 1 byte. Okay, 1 byte. Simple 1 byte. So what is the total number of blocks? Total number of blocks 16 G. We are writing like that. In place of G, we are writing 2 to the power 30. 2 to the power 30. If you are writing gigabytes, means 2 to the power 30. In 16 can be write 2 to the power 4. So you are writing 2 to the power 34. Okay. So minimum 34 bits required to give the address. Minimum 34 bits required to give the address. Okay, minimum 34 bits. But whatever the system is operating system you have installed, that is generating only 32 bits. For these 32 bits, you can only utilize the 4 GB RAM. While how you are utilizing the 4 GB RAM? 2 to the power 32 gigabytes. What is the 2 to the power 32? 2 to the power 32, it will come 2 to the power 32 bytes. This is nothing but equal to 4 gigabytes. Clear? Okay. Now there are various types of memory present in your system. Okay. So now assume that this is your main CPU. Okay, central processing unit. That will contain some inbuilt memory that is also called the register. But that size is very small. That size is very small. That will only hold the address of the next instruction. That will only hold the address of the current instruction, something like that. So that size is very small. If you are talking about that size, maximum it will be 1 KB or something like that. Okay, maximum is your 1 KB. So if you are going to check here, I have already mentioned the different size here. Yeah. So now you can see if you are going to find the size of the register, that will maximum 300 bytes, not more than that. Sorry, 300 bytes. Okay. So if the first one is your basically the register, okay, that is very fast as compared to the, that is similar as compared to the CPU, and this is inbuilt memory. This is inbuilt memory, means the processor had inbuilt some register, and that size is only 300 bytes. Okay, after that one cache is there, that is also similar to your main memory. Okay, that is your L1 cache. Okay, after that one more cache is there, that is called the L2 cache. Okay, then your main memory, that is also called the RAM, and after that the secondary memory is present. This is called the secondary memory, that is also called the hard disk. Your pen drive, CD drive, floppy disk, these are called the secondary memory. Okay, if you are going to the side wide, it will increase. Okay, so if you are talking about the normal system, then the hard disk size it will come like that. Hard disk size is 1 TB, or it will come 512 GB. If you are going for the RAM, the size is normally 4 GB to 16 GB. If you are going for the high processing, then you can use 64 GB, something like that. If you are going for the L2 cache, that size is very fixed. That in terms of MB, something called the 64 MB. Okay. If you are going for the L1 cache, then the size is also small. That is 16 MB, something like that. Okay. I have already mentioned here the size. You can see this one is 8 to 64 kilobyte, 0.5 to 3 MB. If you are going for the main dynamic RAM, your RAM, then this size is approximately 4 GB. But nowadays it is coming 16 GB. It is also coming 64 GB RAM. Okay. If you are going for the speed wise, then this one register is faster speed than the L1 cache speed, than the L2 cache speed, than the 4 GB speed, than your hard disk. Okay, What do you mean by L1 cache and L2 cache? That is similar to your RAM. There is no any difference between RAM and L1 and L2 cache. But if you are going to check this L1 and L2 cache, that is very faster as compared to your RAM. As compared to RAM. So if you are going to access any data in L1 cache, that will take very less time as compared to if you are going to access any data in your main RAM. That if you are going to access the any data in your main RAM. Okay, why the register memory is faster? Because it is already inbuilt memory that is already purchased inside the CPU. That is already purchased inside the CPU. That's why it is called the faster memory. That's why it is called the faster memory. Now you can see simple concept. Okay, now we do that simple. Now we do that this is just like a one keychain. Now we do that this is your keychain of your home. This one is your first shop, okay, inside your society. There is one shop inside your apartment, something like that. This one is the shop outside your apartment, okay. This is your one shop. This is one shop inside the city, and this one is a house seller of one city. Okay, this is your hard disk. Okay, now will tell me if we are going to make Maggie, if you are planning to make Maggie, okay, now will tell me which one will take less time to prepare the Maggie, if the Maggie is present in register or if the Maggie is present in L1 cache, L2 cache and RAM and hard disk. Which one will take the less time? Definitely your Maggie is present inside the keychain. Definitely if the Maggie is present inside the keychain, then in this case it will take the least. Now the concept is very simple. If you are planning to make Maggie, what is your procedure? What is your procedure? First, you have to check inside your keychain whether the Maggie packet is present in the keychain or not. If the Maggie packet is not present in the keychain, then what is your next procedure? Anyone? What is your next step? What you will do? You will go to the apartment shop. You will go to the apartment shop. Okay. Now assume that shop has also not the Maggie packet. What you will do? You will go to the society shop. Okay, now assume that is also not present, then you will go to the city. Okay, if it is not present, then you will go to the house seller, but directly you cannot go to the house seller. You will give one request like that, so I need the Maggie packet, can you bring the Maggie packet from the house seller? No. Okay, so now what will happen like that? If you are going for the next day, then it will come from the factory to the nearest place or factory to the city. After that it will come from the city to the L2. After that it will come from the L1. Then it will come from the register. The similar way the computer is also working. Just you can see. Whatever the data you are storing, that will be stored in your hard disk. That will not be stored in your main memory. Main memory means that the CPU can directly access the memory, that is called the main memory. What are the main memory? Your register is main memory, L1 cache is main memory, L2 cache is main memory, and RAM is your main memory. Why we are saying main memory? Because the CPU can directly access the data present in the main memory, but the CPU cannot access the data present in the secondary storage memory. What is the means problem with that? Anyone? Why you are not directly going to the factory to purchase one Maggie packet? Anyone can tell me? Can you tell me why you are not directly going to factory to purchase one Maggie packet? Because it will take lots of time. Okay, it will take lots of time to go and purchase one Maggie packet from factory. Okay, so that's why normally if you need the Maggie packet, first you are checking in the keychain. If it's not present, then you are checking in the L1 means the first shop, second shop, third shop. Okay, after that, if it is not present, then you are putting your request. I need some Maggie packet. Can you bring this Maggie packet for me? Okay. Okay. Now here you can see the concept is also very simple. This is your CPU. Okay. CPU will contain some register. Okay. Then this one your L1 cache. This is your L2 cache, and this is your RAM. Okay. Now assume that if you have written one simple program, is equal to A plus B. Is equal to A plus B. What do you mean by that? You need the value of A, you need the value of B, and after that you have to sum this two value, and then will store in S. Clear? Means you need the two value 5 and 6, and after that you will make the summation of this two value, and then will store this value in one memory called S. Okay. Now we have given this instruction to the CPU to execute this instruction. What the CPU will take? First, the CPU will check whether A is present in this register or not. Whether A and B is present in this register or not. Automatically, this value is already present in your hard disk. Okay, already present in your hard disk. Just try to understand the concept. Okay, not present. What the CPU will do? It will check in the L1 cache. It is also not present. It will check in the L2 cache. That is also not present. It will check in the RAM. That is also not present. Okay, if it is not present, then the CPU will assign this task to one loader. That is one software called a load. What is the task of this loader? To load the value of A and B present in your secondary storage device, that is called the hard disk, to your RAM. Okay, so it will put this value to your RAM. Sometime it will put this value to the RAM. It will also check the L2 cache. If some memory is vacant, it will also put some data to the L2 cache. Same like that. So first it will check the register. If there is memory vacant, no vacant, then it will check the L1, no vacant, L2, no vacant, yes, vacant in the RAM, so it will put some memory here. Okay, so now assume that this one is assigning for A and this one is assigning for B, and now assume that this value is coming 5 and this value is coming 6. Okay, now the CPU can directly access the value of A and B. Why? Because this value is already present in your RAM. Same like that. After that, now assume that this value here some memory is vacant, so it will also store 5 and 6 here, A and B. When it will store A and B here, this data become the public, something like that. This data become the public. Public means now the anyone can use this data. Now the anyone can use this data. Now assume that you have executed this instruction that will calculate, the CPU will calculate this value and going to store this value is equal to 11. Is equal to 11. Now your task is completed. After completion of your task, this data become the public. This memory become the public. Now anyone can use this memory. There are two concepts. One is called the private memory and second one is called the public memory. Okay. After that, now you can see, after that, again you are giving the same instruction is equal to A to B. Okay. Just you can see, I will give you the idea. Is equal to A into B. Is equal to A into B. Okay. What do you mean by that? Again, the CPU will need A and B. Again, the CPU will check register. No, it is not there. L1 cache, it is already there. It is already there. This value is already there, 5 and 6. So it will not go to the L2 cache and RAM and directly it will calculate the value 5 into 6 equal to 30. But the rarely will get this value in L1 cache. Rarely will get this value in L1 cache. The simple concept. Now we will assume that. The simple concept. Okay. I think you have already visited the railway station. Railway station. Now we assume that this is one chair. Okay. Chair. Okay. Now this is one chair in railway station. What we are going to do? You are going to sit on this chair. When you are sitting on this chair and whatever the item or object you are putting aside this chair, that will consider as a private part. Okay, that will consider a private property, which no one can access your bag, no one can access your object. Whatever the object you are putting here, no one can access your bag or whatever the laptop, whatever you are taking carrying, that will not access. But now assume that, after some time, if you are coming outside your railway station, if you are coming outside railway station, then in this case, what will happen like that? When you are going to lift this bench, automatically this bench becomes the public property. Anyone can use this bench. Can we say? It is not like that. If you are going outside the railway station, this is reserved for you. It is not like that in the common sense. It is not like that. That becomes the public. Okay. Now assume that after 30 minutes, again you are coming to the same batch. Can we say we'll get the back? Can we say we'll get the back? Can we say that we'll get the back after 30 minutes? You assume like that after 30 minutes, what you have done? So after 30 minutes, you are getting like that. I forget my bag in the railway station. So in this case, what will happen? Again, you are coming to the railway station. What is the chances to get your bag? Anyone? What is the chances? Rarely will get the back. Rarely will get the back. Okay, rarely will get the back. Okay, no chances, but you can say sometimes if you are very lucky, 1% chance you will get this back. Sometimes if you are very lucky, 1% chance you will get the back. If you are saying there is no any chance, definitely will not visit next time the railway station. Why you are coming to the railway station? Because you have the probability. There is something probability to get the back. Same like that, just you can see the same procedure. What we are writing like that, now you can see. This is your main memory. Okay, this is your main memory. Now, this is your main memory means already everyone is using the same memory. Whatever the software you are going to execute, whatever the application you are going to execute, everyone will use the main memory. Everyone will use the main memory. Now you can see the size of the main memory is your only 4 GB. What do you mean by that? At a time you can only store the 4 GB. If you are going to check your hard disk, then normally you are storing the data up to 100 GB or you have the 200 GB, something like that. You have the 200 GB. Okay, now you can see your RAM is 4 GB and your hard disk is storing the data 200 GB. Okay, if you are going to access any data, it will only go through the RAM. It will only go through the RAM. But the problem is RAM is only 4 GB. You cannot load the whole 200 GB data in the RAM. Then what will happen like that? Everyone will use this RAM. Okay. As for example, if you are writing S equal to A plus B. Now assume that some data, some garbage value is already present here. Some garbage value is already present here. Some value is already present here. Okay. If you are writing S equal to A plus B, then in this case, first the system will check if there any memory vacant in the main memory or not. If there any memory vacant in the main memory or not. Yes, there are 2 memory vacant that will implies to you. Okay, and you are going to store the value 10, and here the B you are storing the value 15. Clear? You are storing the value 15. Now this memory become your private property. Okay, this memory become your private property. No one can access this memory until your task is not completed. Until your task is not completed, this memory become the private property of your program or something like that. Okay. After that, the CPU has already executed this instruction and they are going to print 10 plus 15 equal to 25. 10 plus 15 equal to 25, and they are going to reflect your data. Yes, you have given me the instruction. I have already calculated the summation of A and B, and your answer is 25. When the CPU will say this answer is 25, this all memory become public. This all memory become public. Okay, this all memory become public. This data is not deleted. Data is already present, but this memory becomes the public memory. This memory becomes the public memory. For other application, if you are writing S equal to C into D, can we say this value is important for this application? Can we say? Can we say whatever the value present in A, can we say this value is important for C into D? No. So for this one, this value become your garbage value. For only for this program, this one will contain a real value. But for other program, whatever the data is there, that will consider as a garbage value. That will consider as a garbage value. Okay. After that, now assume the next time you are giving the same instruction, is equal to A plus B. This memory already become the public. Now assume that during this operation, during this two operation, if no one has used this memory, then in this case, again it will allocate the same memory. Again, it will allocate the same memory if no one had used this memory, but the chances are very, very less. The chances are very, very less. Yes, you can say only 1% chances to get this data in your memory. Okay, so I think your concept is very clear. What we are saying like that, how the CPU is working, how the CPU is handling the memory. First one, the CPU will check whether this data is present in the register or not. If it is not present, it will check in the L1 cache because that is very fast. Then it is not present, that will check in the L2 cache. Not present, it will check in the RAM. If it is not present, then it will assign one task to the loader to load the data from secondary storage device to. Okay. After that, if some backend seat is there, then it will store here, and then it will come to something like that. And I have already given the example of Maggie, the same like that. First, we are going to check in the keychain. If the Maggie is not present in the keychain, first we are going to the apartment shop. If it is not present, then you are going to the society shop. If it is not present, then you are going to the CT, if it is not present, then you are only giving the request. You are not going to the factory. You are not going to the factory. This is a simple concept of the memory management system. Now the question is, why we are not going to increase the L1 cache? Why we will not take the RAM of something called 108 GB or the RAM of 100 TB? You have one this type of question. Why we cannot take the RAM of 1 TB? Anyone? Because this is very expensive. This is very costly. Because when you are getting any system, when you are getting any requirement, you have to develop the system within that budget. Okay, with maximum memory, with maximum. Okay, so that's why it is coming lesser. So if you are going to say, it will check this types of parameter will come. This one is your size. This is the size of the register. This is the size of L1 cache. This is the size of L2 cache. This is the size of RAM, and this is the size of your hard disk. If you are going to go to this side, then per unit memory price is going to high. Means this your price will increase, and if you are going to this side, this is the space will increase. Something like that. So you will get the one pyramid type of thing. First one, your register, that is very small inside, but that's if you are going to check, that is also very expensive. But if you are going to check the access time, that had very low access time as compared to L1 cache, as L2 cache, as compared to RAM, and as compared to hard disk. Okay, I've already given why the larger size RAM is expensive, because it will. If you are going to design the RAM, you have the two objectives. The first one objective, you have to increase the speed of the RAM. You can increase the speed of the RAM, and when you are increasing the speed of RAM, that will take the more cost. That will take the most cost. Okay, clear? So I think your memory management is clear. How it is working, that is clear. Okay, now we are going to the main part of the computer program. How it is working. Okay, how it is working. So first one, whatever that code you are writing, that is also called the source code. So as for example, we are writing one simple program here. We are writing one simple program, but before that, we go for one function. Okay. So you already know the function concept. What do you mean by function? Anyone? Can you tell me if you are writing f of x equal to 2x plus 5, if you are going to calculate f of 3, what is the value you will get? What is the value you will get? Anyone? 2 into 3 plus 5 you are getting 11. Okay. Function means, just you can see, function means that will take some input and it will give you some output. Okay, so there are two parts in one function. If you are talking about the programming point of view, there are two parts. One is called the function declaration, and second one is called the function definition. Okay, declaration means that will contain what is the name of the function. So if you are writing f is the name of the function, what types of value it will take as an input. Okay, so you are saying integer. So as for example, if you are defining one function f of x equal to x factorial plus 5, what is the value it will take? X factorial. What is the value of x? Anyone can you tell me? Can we calculate the value of f of 2.5? Can we calculate the value of f of 2.5? No. Can we calculate the value of minus 2? Can we calculate f of minus 2? No, we cannot calculate the factorial of negative number. So normally you can say x is your integer value. If you are writing this type of function, what you are saying like that, this function will only work. This function will only work. Right to understand, this value function will only work if you are taking integer, and that value must be greater than 0. That value must be greater than 0. If you are saying like that, just you can see, this is a function f that will take x as an input, that will take x as an input. Okay, and the value of x greater than 0, and x always your integer. Now this is a function. If you are saying what is the value of f of 2, anyone can tell me what is the value of f of 2? Anyone? F of 2. What is the value of f of 2? Blindly you cannot give the answer. What is the value? Now I think blindly you are giving the answer. I have not defined the f of x. What do you mean by f of x? We cannot say anything. I have only given this is a function. The name of the function is f, that will take the input x greater than 0, and x is your integer, and then I am asking what is the value of this function. How can you say like that 7 and 2? We need the definition of this function. What is the definition of this function? The definition of this function is f of x equal to x factorial plus 5. This is called the definition of the function, or also called the logic of the function. Okay. So any doubt means this is called the declaration. This is called the declaration. Means you are only giving the syntax of the function. What is the syntax of the function? The name of the function is f. That will take only one input. What is the type of the input? The input is your integer, and that must be positive integer. That not be a negative integer. Then you are going to define the logic. What is the logic of this function? F of x equal to x factorial plus 5. This is called the logic of the function. Okay, this is called the logic of the function. Okay, there are two types of function. One is called the predefined function, and second one is called the user-defined function. If you are talking about the computer point of view, there are two types of function. One is called the predefined, and second one is called the user-defined. Okay. Predefined means it is already defined. You are not going to write the code for that function. It is already defined by the software. Whatever the software you are going to download, it is already defined. User-defined function means you are defining your own function. That is called the user-defined function. That is called the user-defined function. Predefined function means already defined. You are not going to write the code for predefined function, but the user-defined function means you are writing the code for user-defined function. Okay, so we will take one simple example, and after that in the next class we will see more detail about the compilation process of computer program. Okay, so I am taking one simple file. Here it is already there. A.c. Okay, so now here you can see. Here we are writing here. In sum a comma b, a comma b, okay, return a plus b. Okay, return a plus b, and here we are writing printf percentile b, and we are writing here sum of 5 comma 6. Sum of 5 comma 6. Yeah. So now you can see it is printing bits 11. It is printing bits 11. Now here you can see we are not writing any code for printf function. We are not writing any code for the printf function. That is called the predefined function. And here we are for the sum. We are writing the code for the sum function. That is called the user-defined function. So here we are defining this function, user-defined function, and this is already defined. This is already defined. Where it is defined? It is defined in studio.h. So that the next class we will see more detail about what do you mean by studio.h, what do you mean by hash include, how you can design your own header file, what do you mean by library, how we are working, how the compilation or the compiler will convert this high level language to low level language. So in the next class we will see that is very important, and the next one is very important because we are going to start the flow chart in next class. Okay, we are going to start the flow chart in next class, and definitely some question will come in your midterm exam related to flow chart. Okay, so that is a very important topic, flow chart. So if you have any question, then please ask. If you have any question, then please ask.
Sir?
Yes.
Sir, I have a doubt regarding the loader, the function of the loader. So it loads the variables into the RAM.
Yes.
Does it also copy the variables into the L1 cache and the L2 cache, sir?
It will also copy the variable. The loader task of the loader is to load some data, some instruction, some program from one memory to another memory. That is the task of the loader.
Sir, so where does the actual like the ALU, where is it present, sir? That's where the
ALU is the different part. ALU is only responsible to do the arithmetical and logical operation. So if you are giving the instruction 5 plus 6, it will be done by the ALU. Control unit, it will give all the instruction. It's just like a principal of your college, something like that. So it is giving all the instruction. ALU just like a faculty of the college that will execute the instruction. Loader is the security guard, something like that. That will take the copy from the academic block that will give to you, something like that. Is the task of the loader.
Sir, like now we are adding two numbers, right? So it has to take place in the ALU only, right, sir? Because it's an arithmetic operation.
No, ALU only will do the arithmetic and logical operation. This is just like a function. It will not store the value. This is just like a function that will take the input, it will execute, and it will store in the memory.
Yes, sir.
This is just like a one machine. This is just like a machine where you are giving some input, it will process the input, it will give you the output. but it will not store your input, it will not store your output.
Yes, sir. Sir, I have another doubt.
Yes.
So, like when we say s is equal to a plus b, and the sum is stored in the variable s, right, sir? So, when does that variable go public, sir?
Yeah,
Like,
public means after completion. Now you can see. So after completion of this program, this variable become public.
I mean, like when we click on run, then the program is considered to
Yeah.
be finished.
Yeah, when you are clicking the run, it will reflect your output. After reflecting your output, it will assume like that your task is completed and it will assign to the software.
Yes, sir. So A and B also won't go public until then.
Yes, it will not go public until then. That will see more detail when we will discuss about the means what we can say the is variable. When we will discuss about the variable, that time we will discuss. Okay, so one question is coming: if one row contain up to 11 bits, then but one cell is only 1 byte. Would not be any. What I'm saying like that, the size of the cell is fixed. The size of the cell is 1 byte, 2 byte, and 4 byte. One row we are not saying that. We are saying the size of the address is 11 bits. Size of the address means in front of the room you are writing the address. That will take 11 bits. Inside the room, whatever the item you are going to put, that will contain 1 bytes. You can only put 1 bytes inside the room, but when you are writing the address, you are using the 11 bits. Clear? Any other doubt?
Sir, I have another doubt.
Yeah.
Like, I mean, why is it necessary that the variable should be transferred like from the RAM to the L2 cache and then from L2 to L1? Why is it necessary? Why not directly from the RAM to the CPU register?
Yeah, so why it is coming like that? So now you can see I've already mentioned that has the limited size. That has the limited size. Okay, CPU will responsible to execute all the instruction. Okay, it will not wait for the other instruction because when you are designing the software, there is also one requirement to effectively utilizing the resources. Okay, so CPU will effectively utilize the resources. Now assume that you have given one instruction and the CPU is going to access this data from RAM. It will take more time. Definitely, it will take more time. Okay. Now assume that the normal cases, if you are going to assume like that, now you can assume like now this is your CPU. Okay, and there are 2 tasks up there, T1 and T2 and 3. Now assume the 3 tasks. Okay. CPU first decided to execute the T1 task. When they are going to execute the T1 task, if the data present in L1 cache, it will take 1 nanosecond. If the data present in L2 cache, it will take 3 nanoseconds. If the data present in the RAM, it will take 1 millisecond, something like that. Now assume that if the CPU is going to execute the instruction, if the data present in L1 cache, how much time it will take? 3 nanoseconds it will take to execute all the 3 instructions. Okay, but if the CPU is for all the instruction, if the CPU is going to RAM, then CPU is ideal for 1 millisecond because the data will transfer from RAM to your register or RAM to your L1 cache. That time the CPU is idle. That is not the best way. That is not the best way for your system. So in this case, what the CPU will do, the CPU will assign this task to the loader to load this instruction, and after that the CPU will check the T2. After that, the CPU will check the T2. Then the CPU will check the T3. Same like that, the doctor. Now assume that doctor is giving some prescription, something like we will go for the blood test. After that, the doctor will not wait for your blood test report. It will go for the next patient. It will go for the next patient. But now assume that if your doctor is waiting for your blood test report, what will happen? After completion of one patient, then it will go for the second patient. What will happen like that? What is the problem with this approach? Just to tell you, what is the problem with this approach?
So, like, it should always go from the slower to the faster, right, sir? Otherwise, it'll take more time.
No, it is not like that. Those it will come first, you have to give the first priority. It is not like that. Now assume that these are patients are the patient one, number 1, 2, 3, and 4, and one patient is 5. You cannot directly give the priority to patient number 5.
Yes, sir.
You cannot give the directly to patient number. You have to go with the sequence order or some other algorithm is also there. That will get more idea when you will study about the operating system. That we also call the CPU scheduling. So there are the various types of approach are there, how to execute the instruction that will decide by the CPU. Okay, so there are various types of first come first serve, then it also come last come first serve, then it also come the priority based. If you are getting the emergency case, then first we have to give the service to that patient, something like that.
Yes, sir. Sir, so we have 3 copies of the same variable, right, sir? So, I mean, like we have in T1, T2, and T3, we have the values of A and B, right, sir?
Yes.
So it's not necessary that the values of A and B in T3 will go public because we don't need them. It's not like that, right, sir?
No,
They'll still be
that,
present.
no. What I am saying like that. It is, you are asking the question like that. Now assume the 3 passenger is traveling with the same type of bag. Can we say all are same?
No, sir. Like they have different memory addresses in this
Yeah,
case.
they have the different memory. Even if you are going to write A in the case of one program, and if you are writing A in the case of another program, both are totally different. You cannot compare with the A present in one program and A present in the different program. Both are totally different. You cannot say like the same. As for example, mark sheet of the different student. There is one variable called math marks. Can we say the same for all the students?
No, sir.
No, the same like that. You cannot compare. Once this is completed, that becomes the public. Anyone can use it. Anyone can use it.
Yes, sir. Then all 3 sets of variables will become public at the same time, which are present
Yes.
in okay,
Yes.
sir.
Sir, I have a doubt.
Yeah, please.
Sir, when you're saying that it is going public, you're talking about that particular location in memory, right? So now you can store something else in that memory. That is what you mean, right?
Yes.
Yeah.
Means
Okay.
you are going to free the memory. When your program is executed, no one can use your memory. No one can use the memory present in the RAM. Okay?
Yes.
Means
Sir.
whatever the memory allocated by the CPU. Once you have completed the program, that memory becomes the public. Means everyone can use this.
Yes, sir. That was my doubt. Thank you.
Okay, please share your email ID.
Sir?
Ria Agrawal. Yeah, please share your email ID in the chat.
Sir?
Yeah, tell me.
Sir, if we write like S is equal to 11 and then immediately in the next statement we write S is equal to 35. So does the previous variable, is it freed, the memory?
No. It will write the same place.
Okay, so it'll just replace that data.
Yes. It will replace the data. At a time, it will store only one value.
Sir, will we learn more in detail about the L1 cache, L2 cache in
No,
later?
that is the part of computer organization. Okay. Mainly during the C program, we will discuss only about the main memory. Okay. So whatever we have discussed in today's class. So that is sufficient for C program. And that is also very important.
Yes, sir. So it's from L1 cache that the data goes to the CPU registers, right, sir? Always.
Yeah, see, it is not always compulsory to get L1 cache, L2 cache in your system. Okay. Mainly your system will contain CPU with register, RAM and hard disk. Okay. If you are going for high performance computer, then it will increase the performance by putting L1, L2, L3, L4, L5, L10 cache. Okay. Why they are putting? To increase the performance of your system.
Yes.
If you are taking the low performance system, it is only present the CPU, RAM and hard disk.
Yes, sir.
Thank you, sir.
Thank you.
Thank
Any
you.
other doubt? Yeah. Anyone, any question?
Thank you, sir.